Fixture profiles are what tell the console which DMX address is mapped to each parameter of your fixtures. Profile types are assigned to channels in Patch. There is an extensive stock library of profiles in the software, but any specific profiles used in a show are saved in the show file itself, including any edits you make to them. This ensures that your show will always play back consistently. EOS allows you to manage and edit these profiles using the fixture editor. Let's explore the editor and see how it works. To get to the editor, we're going to want to go to our patch screen. And notice how my dimmers have an asterisk in front of them. I'll explain that in just a moment when we get into the editor. It is related. So I'm going to hit the Fixtures soft key. If you have any channel selection, this soft key will not be there, so you may need to clear your command line in order to see it. So this opens up the fixture editor, which is divided into two main portions. On the left, we have our list of fixtures in the show file. You'll notice the one at the very top is grayed out. So what that means is that fixture type is stored in the show file, but it's not actually patched in our show right now. You'll also see that all of my fixture profiles currently have an asterisk here. So just like the asterisk in Patch, what this means is that the profile in the main EOS library is different than the fixture profile we have here in this show file. This could have been because the library has been updated since we patched this show, or it could mean we've made edits to the fixture profile, which then makes it different from the library. Changing a fixture profile, whether you're making edits yourself or updating the profile to match the library, can affect how your show plays back. So use caution when doing this. It's good practice to save your show file first before doing any profile updates, just in case you need to go back. To update a fixture profile, you'll want to select the fixture that you want to update. Let's do the SolaFrame 750 and select the Update Profile soft key. This is going to show you a list of changes that are going to be implemented when you press OK. I'm going to go ahead and do that. And you'll see now we don't have an asterisk in front of that fixture profile. There is also an Update All button. Now, if you use this one, you won't be able to see the specific changes since we're doing more than one fixture at a time here, but you do get a warning telling you to use caution. For today, I'm going to cancel. The columns here on the left side are the type, so that's the fixture type, of course. The next column shows the DMX footprint, so that is how many addresses each of these profiles uses. And the final column is cells, which for any multi-cell fixture will show you how many cells there are. We can expand any multi-cell fixtures using the arrow here, and that will break that down. And now I can go into each cell and look at the parameters within those. For now, we will close that back up. I'm also able to remove unused profiles from my library. If you have a base show file or a show file you use over and over, it's possible to accumulate a lot of fixture types from previous shows into the library. We can delete those one at a time. So if I select a grayed out fixture, I now have a delete soft key down at the bottom that I can use. Or if I have a lot of them, I can use the delete unused soft key, which will remove all of those in the show file. This is a good way to clean up your show file if you're sure that you won't need to use these profiles again. Let's take a look at our iRGBA fixture here. So there is an asterisk there, so I'm going to go ahead and update that profile. It looks like there's not too much changing here, but again, it's always good to be safe. I will update that, and our asterisk has gone away. Now let's take a look over on the right-hand side of the screen and look at what this particular profile contains. So this is laid out in sort of a spreadsheet format, and we can see the fixture name at the top along with the footprint and parameter count. I'll talk about why those numbers are different in just a moment. We have several columns. The first column is a number column, and this is simply the order in which the profile is constructed. It has nothing to do with the DMX addresses of these parameters. This is sort of akin to actions in an effect. The next column is parameter, and the white words are the actual parameter names. and we can edit those and add those, and we'll look at that shortly. And then the next column, which is grayed out, is the parameter category. So this cannot be edited. So for example, red can only be in the color category. The next column is our DMX address. So this is in relation to the starting address. So for this fixture, if it was starting at, say, DMX address 21, then intensity would be 21, red would be 22, and so on. 8B stands for 8-bit. We'll talk about 16-bit in just a moment. And then our final three parameters here are virtual. These are parameters that are calculated by the console, but it's not actually outputting any extra DMX. So what this allows us to do is control fixtures in various ways. So for this fixture, we can modify the red, green, blue, and amber parameters directly, or we can use the virtual hue, saturation, and brightness settings on our encoders or in our ML controls, which will calculate the RGBA values for the fixture. Again, virtual parameters do not increase how many DMX addresses are being output by the console or how many addresses the fixture is using. It's simply a different way to control the existing addresses of a fixture. The next column is our home value for each parameter. You can see intensity is going to home at 0, and each of our colors are going to home at 255, or 100% of the DMX value. Remember, DMX is on a range of 0 to 255, not 0 to 100. The snap column can be toggled on or off, and what this will do is override any Q timing for these parameters. You'll see this fixture is not using it, but we will see those in a little bit. It's very common for moving lights to have snap on things like gobo and color wheels. The final column is the ranges column. Each of these parameters has a single range, which mostly are 0 to 100. We'll explore this a little more shortly. When trying to create a profile for a fixture that is not in the EOS library, it's usually best to try and find a fixture that is close, perhaps by the same manufacturer or perhaps from the generic library, rather than starting from scratch. So let's look at how to do that first. I'm going to go back into Patch. I'm going to use my Patch soft key down here at the bottom, which will get me out of the editor and back into the main Patch area. And I'm going to patch a new fixture that we haven't used yet. For now, I'll just put that on channel 11, and I want that to be a SolarSpot 1000. We'll use the standard mode. And as soon as I assign that to a channel, it has now been added to my fixture library and will be stored in my show file the next time I save. To illustrate this, I'm now going to unpatch this, and I know we just patched it, but I'm going to unpatch that channel. I'm not going to delete it, but I'll use the unpatch soft key. And now I'm going to clear my command line and go back into my fixture editor. And you'll see we now have a SolarSpot 1000 standard in the library. It is gray because we have unpatched it. So let's go ahead and select that fixture and take a look over here. At the very top of our parameter list, we see that pan and tilt now say 16B or 16-bit, and they have two DMX addresses for each parameter. This is very common for pan and tilt, and it's often used for other things as well, like edge, sometimes for color, sometimes for intensity. And what this does is for parameters where 256 steps is not enough, which is what one DMX address will allow, is it uses two channels so that we get over 65,000 steps, which is 256 squared, so that we have a lot more granularity when using these parameters. Pan and tilt are the most common parameters to use 16-bit, and it's also easy to understand why we need more than 256 steps. Say we have a moving light with 560 degrees of pan. If we only had 256 steps to get through that entire range, that moving light would move really choppy and it would stutter as it kind of bounced from one side of the stage to the other. So to smooth that out, we use a second DMX address, which gives us 256 times 256 steps, which is over 65,000 steps, which is much more granular. So that's why we use 16-bit parameters. To show that, I'm going to click on the 16-bit box here, and you can see we have our 16-bit or 8-bit option, and we have our DMX address and our low DMX address. So for this one, they're sequential, which is typical. So 1 and 2, and then tilt is 3 and 4. The home value is 32,000 and change, which is halfway between 0 and 65,535, which means it will home in the center of its pan and the center of its tilt, which is typically what we want. Now let's take a look at ranges. In our previous profile, they were all 0 to 100. So now we have a -270 to 270 range. I'm going to go ahead and click on that so we can dive into that a little bit. So the range area is divided into two main columns, which are DMX and user. So the DMX columns are what the console is actually outputting. The user columns are what the user sees displayed in the encoder displays and in the live table display. So our pan parameter here can go from 0 to 65,535, and there's its home value. And those are the actual mathematical numbers being put out by the console, but that's not very helpful to us as programmers. It's much more useful for us to see the actual degrees of pan that the fixture is putting out. So that's why we set the user values to -270 and 270. That's because this is a 560 degree fixture. And we set that home user value to 0. So when the fixture is actually panned 270 degrees one way, the console is outputting 65,535. Let's look at one more. So I'm going to come down to zoom, which is way down here at the bottom. Here's another example. So this is a 16-bit zoom channel, and it has a zoom range of 11 degrees to 45 degrees. And again, it is easier for a programmer to understand, say, 26 degrees instead of a large number of DMX that isn't going to mean a whole lot. I'm going to click out of there. Let's make a few changes to this profile and see how we do that. So for this example, I'm just going to swap our pan and tilt. We'll say for some reason this fixture had its wiring crossed and we need to switch its pan and tilt. So I'm going to click in this field and I'm going to make that be 3, and the low DMX will be 4. And now my tilt should be 1, which is already there, and 2. So we've swapped those. And the other thing I want to change is our iris range. So this is common sometimes with fixtures. You'll get them and fire them up, and you'll see that the iris defaults to closed instead of open. So an easy way to do that is to change the home value. So this one defaults to full, which is what I would expect. But for this example, let's open up the range here. And I just want to show this. We're not going to change anything in the range. I just want to point it out. So the DMX minimum is 0, max is 255. It homes at full as well. And then the user values are simply 0 to 100. So pretty simple and standard range there. So if we come out here and change our home to 0, and then check our range again, you'll see that this has also changed. So our user home is now 0, as well as our DMX home. We'll close out of there. So while it is possible to change home values here in the fixture profile, and that may be valuable if you use fixtures and you know you always need the home value to be different. For example, if that iris defaults to closed instead of open or something like that, and you're always going to use that profile moving forward, then editing the fixture profile is the way to go. But also don't forget about your home preset. So the home preset is going to supersede the fixture profile. The fixture profile is sort of the last place the console looks for home information. If there's nothing in the home preset and there's nothing in a queue and it has to put it at its home value, then it checks the fixture profile. So for many applications, a home preset is going to be a cleaner and simpler way to edit those home values. All right, next let's take a look at dependent parameters. I'm going to scroll back up here. And I want to look at gobo wheel mode. So you'll see it's gray. And if I click in the ranges, it says 5 ranges here, and you'll also see it is a snap parameter, like I mentioned. We typically don't want gobos or color wheels to use the queue timing. If I'm going between gobos, I don't want to see it fade, through the wheel. I just want it to go to my gobo. That's what that snap does. So if I open up the range here, at the top of this box, you'll see we have a note that it tells us what this parameter is dependent on. And we see here it is gobo select. So these two parameters, even though they are separate DMX addresses, they are tied to each other. So here we have 5 ranges. They're labeled whole, spin positive, spin negative, whole scan, and random. And you can see all of the DMX and user values for those, which happen to match in this case. So I'm going to close that out. And next I'm going to look at the gobo select ranges. So instead of ranges, you'll see that it has modes. This one has 4 modes. So if we click into here, on the left side of our pop-up, we see the different modes. So what this does is when you're using the gobo select parameter, the first thing the console does is check to see what the gobo wheel mode parameter is up to. So if I click on the mode here, if gobo wheel mode is in whole or whole scan, then these are the parameters we have available. We can go to these gobo slots. If gobo wheel mode is in spin positive, then it's going to send the DMX address in this range, which is just 0 to full. And the user actually sees 0 to 60. And if it's in spin negative, then it's going to do the same thing, but it will spin backwards. And same for random. To understand this a little bit better, let's take a look at the DMX chart from the manual of this fixture. So here I'm looking at DMX address 12 and 13, which the console calls gobo wheel mode and gobo select. The terminology in the documentation is slightly different, which is going to be very common. So if we look at address 12, we can see that when it is what the manual calls indexed, scan, and blink modes, these are our ranges to get solid gobos, in the slot lined up. But if it is in spin or random modes, then it will move from slow to fast when we change this DMX address's values. And then in the manual, if we look at address 13, you'll see the different modes here, which we call the ranges in our gobo wheel mode parameter. And just a quick note, I'm going to open that parameter back up here. The reserved function in the manual, the reserved function is not used. So you'll see our profile, the highest DMX value we go to is 79. We don't use 80 through 255 at all. Let's close out of that. All right, so in our list on the left, you can see as soon as we change something, it's going to turn red and give us a note that says unsaved edits. So let's go ahead and save this fixture for the moment. Click our Save Fixture button up here. And when I click off, you can see the SoloSpot 1000 is still gray because remember, it's not patched into our show, but it now has an asterisk. And that is because we have modified it from the fixture in the library. So while it is possible to edit the existing library profiles, it is often a better practice to make a copy and rename it so that you know that it is a custom profile you've worked on. So to do that, I'm going to select it and say copy. And then I'm going to select the copy and use the label soft key. And I'm going to append a label to that so that we know this is our edited copy. And I will need to use that Save Fixture button again to save the label. So now they're both gray. So let's go ahead and assign our new fixture profile to a channel. I'm going to use my patch soft key, and I will go ahead and put it at channel 11 for now. We'll say type. Now it's important to point out that the manufacturer and search boxes will only find fixtures in the EOS library. For any custom fixtures, we'll have to look in our Show tab. So here it is. It's currently gray because we haven't used it yet, but we can go ahead and assign it here. And for the moment, I'm going to give it an address. We'll say it's universe 21 address 1. Let's go out into live and select our new fixture. I'm going to press my About button, and under the Patch section here, I'm going to look at a couple of things. I can see that my pan and tilt are swapped. So typically pan would be 1 and 2. You can see here it's 3 and 4. And I can see that my iris has homed to 0 instead of 100. Let's open up our encoder display, and we're going to go to the image category and talk about those ranges one more time. So you'll notice on Gobo Select, if I open that up, when I'm on whole, I have the option to pick a gobo. That's very useful. But if I switch to spin, those gobos disappear, and now I can, using my ML controls, I can move that range up and down. So I can spin quickly, and this is just going to rotate the wheel. Now, as soon as I switch back to whole, and I'll do it in ML controls this time, that same parameter, that gobo select, now if I move it, it's going to select gobos instead of changing the spin speed. So while in ML controls and our encoder display, everything is under the umbrella of gobo select, because we dug into the fixture profile, we now understand that gobo select is made up of 2 parameters, the second one being gobo wheel mode, and gobo select is dependent on which mode that is in. Let's go back into our editor for just a moment, patch and fixtures. As I said earlier, modifying an existing fixture is often the best route to take to come up with a new profile for a fixture that is not in the library. However, if you do need to start a brand new fixture from scratch, you can do that here as well by clicking this plus sign, which will create a new fixture. Now we're going to default to a single parameter, which is intensity. From here, we can give it a label. And in the editor, we can add parameters using this plus sign. Anytime we click it, the console is going to make a guess at what the next parameter would be, but we can always edit those. So it put pan here as a guess, but I can click that and I come up with a pop-up that contains common parameters here. And if I go to, we'll say color, it will show me every color parameter that is in any profile in the console. So this can be a little overwhelming trying to search for fixtures. So fortunately, we have our good old search box here, and I can just type and it will display all parameters containing anything I type. So I can double click and that will assign a parameter. The parameter category will always be automatically assigned. Again, that cannot be changed. If I need to delete parameters, let's get rid of these virtual ones for now. I can use this delete soft key. I'm going to delete all of those. And if I need to insert a parameter above an existing parameter in the chart, I can use the insert button. So in this case, it will insert it above zoom. Once you're done adding all your parameters and setting their data, don't forget to click that Save Fixture button. Then you can patch it to a channel, and of course, make sure you test it before you start programming.